Okay, if you haven't seen this question before, you should probably pause the video and try to figure it out first, because it's going to let you know if you really know what you're looking for in a question like this, because this is a decently interesting and tricky question if you don't know the different ways that you can analyze these pedigrees. So the first thing that you might be assuming, well, the question is just asking you what are the genotypes of the parental generation. So that's these two people right here, the mom and the dad. It's just not breaking any normal rules. The circles represent females, the squares represent males, and they have a key here if you're unsure about that. And if they're filled in, it means they have a trait. What you need to do when you have these questions, though, is you need to ask yourself two questions. If they don't give you that information, you have to be asking yourself, is this trait, whatever it is, and it doesn't matter what it is it inherited in a recessive or a dominant fashion? Because that's going to change things up. And the second question you should ask yourself is it inherited in a autosomal fashion, or could there be sex linkage? And if I remember, I'll give you some quick tips on how to kind of guess whether these things are actually happening or not. But normally what you might do is you might just start by going, okay, with recessive and autosomal. So that's your standard big B, little b, and no X chromosomes are involved here. So let's just do that. And I'll start with the assumption here that big B, let's just use the letter B. Well, big B means normal and little b means has the trait, whatever it is. And they haven't told us what the trait is. If they told us and it's something famous that we know about, like colorblindness, then I automatically know that it's going to be sex-linked recessive. But here they want us to figure out what are the different possibilities. So assuming that this is the case, so let's work through this. So if little b causes the trait and a big B will actually hide that, well, this female here has to be little b and have to have another little b. If it had a big B somewhere in there, it wouldn't be filled in, it'd have to be normal. This dad here has to have a big B because it's normal. And you might be asking, well, could it be big B, or big B, little b? Could be both, but let's look at the next generation. Down here, their kids, they've got 4 kids here. They've got a daughter here that has to be little b, little b. Now, just by looking at this situation, from Mendel's law of segregation, in order to form this girl daughter here, each of these alleles had to come from different parents. So obviously, this mother had to pass on a little b, so that takes care of that little b. So where did this other little b come from? Well, it has to come from the dad. So that means this dad has to be big B, little b. I think I have enough information to be able to try to look through these answers and see what's going on. So if this is the case, if it's a recessively inherited trait and it's autosomal, then let's see if I can find an answer here. So I can see that my mother is homozygous recessive and the dad is heterozygous. And if I look through these answers here, the male is homozygous dominant. Nope, that doesn't work. The male is heterozygous, yes, and the female is homozygous dominant. Okay, that doesn't work. The male is homozygous recessive, that's already wrong. And the male is homozygous recessive, that's already wrong. So what's going on here? We don't have any answer that actually fits this. Well, that's because it's probably not inherited in this recessive autosomal fashion. Now, there are some shortcuts to try to figure this out, but really, if you understand the basics, it's worth it to invest the time to figure out these types of genetics questions, and you can be sure that you're getting yourself to the right answer. I mean, I'm fine that I or my students or anybody else, you've got to invest some time into these genetics questions, and you can always find your way to the right answer. So let's change colors here, and I'm going to try a different model. So now I'm going to try the other way, if it's dominant and autosomal. So dominant autosomal, if I start with that, then let me switch these letters around. So I'm going to go with big B means you have the trait. So that causes the trait, and little b means you are normal. So let me reevaluate here. So I'm going to get rid of these. Don't have time to erase it, so I'm just going to start. Let's see. Normal. So if the normal dad right here and little b causes normal, then he has to be little b, little b. If he had a big B in there, then his blocks should be filled in. So little b. This mom here has the trait, so she's got to be at least a big B. And what about her second allele? Well, let's look down here. She's got some kids, and the kids are normal. So if there are normal kids, and by the same rule we said before, if this B came from the dad, this other little b had to come from the mom. So that means mom has to be like that. Okay, does that work out for this kid? So this daughter, she has the trait, so she probably has the big B. And the other letter, the other allele, had to come from dad, so she has to be heterozygous. I think I have enough information from there, so let me go and read through these and see if this model can result in finding a correct answer out of here. So these are my new genotypes that I'm looking at, okay, in blue. The male is homozygous dominant. That's still wrong. Oops, where did that line come from? Ignore that. B, the male is heterozygous. That's wrong. C, the male is homozygous recessive. Okay, that looks good. And the female is homozygous dominant. That's not correct. And how about D? Hopefully this works. The male is homozygous recessive. That works. And the female is heterozygous. So you see, in this case, we have to understand that there are different ways that traits can be inherited, and so that's leading us to the correct answer of D. Now, how do I know it's not sex linkage, and that I don't have to go through and try, recessive sex linkage, then dominant sex linkage? Well, one quick tip, let me erase some of this stuff. If you need to see it, just, oh no, that doesn't work. Cannot do that. Anyways, how do I know it's not sex linkage? Well, if I look at the number of boys that are affected in this entire pedigree here, there's 3 boys that are affected and 2 girls that are affected. If it was sex linkage, it'd probably be a greater proportion of boys being affected compared to girls. And that's one tip for finding out if it's sex linkage or not. Another quick tip to find out if it's recessive or not, which I couldn't find here, is if in any case you have 2 parents who are not affected, you probably know this already, and if you find that they have a kid that is affected, well, the only way that you can have 2 parents that don't have the trait and then have a kid that has the trait is if it's recessive. And in this case, I didn't see that. So although I tried starting off with the recessive thing, it could still be recessive and it could still be dominant. So you can see the results here are showing it might work. I didn't go all the way down into this generation right here, but already seeing that it didn't work here helped me to figure out what the correct answer was. So again, these questions take a little bit more time, and sometimes if it's a short answer question, it's a lot easier to just do the crosses, find the genotypes, and write down the answers. But when they give it to you in multiple choice form right here, you really have to make sure you understand this in full and go carefully, step by step, to actually lead yourself to the right answer.